Hello everyone, very good morning to all of you. Yesterday we have studied about complex analysis. We have discussed about simple and basic things about complex functions, how to solve them and how to extract information from the complex in equations. Today we are going to study about complex integration. Okay, so we know that all the analytic functions are path independent. So suppose we have a integration here, complex integration, that is called here, limit is 0 to 1 plus iota, and we have to integrate it over these two paths: a straight line from 0 to 1 plus iota, 0 to 1 plus iota straight line, and the polygon line from 0 to 1. This is the line 0 to 1, and from 1 to 1 plus iota. We have to solve this. Okay, so we know that complex integration are path independent. So whether you calculate this way or this way, path A or path B, the value of integration will be same. Function is z square, which is a polynomial, and we know that all polynomial functions are analytic functions. Just simply do the integration and you will get the value minus 2 by 3 1 plus iota. Suppose if it is a closed integration, means if you are starting from here and coming back to this way, B to A and again coming to B. In this case, the value of integration, closed integration, will be 0. What is this? The value of integration of analytic function over a closed contour is always 0. That is, closed integration of fz dz over a closed contour C will always be 0, where function f of z is analytic over a closed contour. Now suppose if we have this function 1 upon z square plus 2z plus 1, we can write it like this: 1 upon z plus 1 ka whole square. So f of z is not analytic at z equal to minus 1, because z equal to minus 1 is singular point here. At z equal to minus 1 it will be 0, and 1 by 0 is infinite. Function is not defined at z equal to minus 1, so function will not be analytic at this point. Now we have another function, closed integration 1 by z dz, and what is C? The contour is unit circle centered at origin. This is the contour, and it is given to us z equal to mod of z equal to 1. So z is r e iota theta, r is 1 unit radius, 1 e raised to the power theta, and 0 to 2 pi whole circle. So what will be the integration of 1 by z? 1 by z dz, when you differentiate it to iota e raised to the power theta d theta. Okay, so after solving, what will you get? 2 pi iota. This is mod of z equal to 1 is defined is a circle of unit radius and center is 0, 0. Now if contour is mod of z minus 2 is 1, then what is defining it? It is showing that circle of unit radius, but the center is 2, 0. So here also 2, 0. Now we will study about Cauchy's integral theorem. Suppose C is a closed contour and a region is enclosed by this closed contour, and in that region function is analytic. So f of z dz over the closed contour C will be 0. Integration will be 0. Always remember, if we have a closed contour C and function is analytic in that region R, then the closed integration of fz dz, that function with respect to the variable over that closed contour C, will always be 0. Now Cauchy's integral formula, what is defining it? fz equal to 1 by 2 pi iota fz by z minus z naught dz, where z equal to z naught is clearly we can see it a singular point, inside the contour C. Now what will happen if that point lies inside the contour C? If the point, singular point, is lying inside the contour C and functions analytic function on and inside contour C, then what will happen? We will first derivative of that function or about that point, singular point, fz0 prime will be 1 by 2 pi iota integration closed integration over that closed contour f of z by z minus z square dz. We have to remember it. Similarly, n times of nth derivative of that function will be factor 1 by 2 pi iota f of z minus z naught raised to the power n plus 1 into dz. What does it means? It means, suppose we have a gz function and gz can be written as f of z by z minus z naught raised to the power n. So we have to arrange this gz in terms of fz and z minus z naught in a way that this function should be analytic in contour C. Okay, this function should be analytic in contour C. Let's understand it by example. We have again same question, and z minus 2 is here, and you can say z equal to 0 is singular point because at this point function is not analytic, and when you draw this contour you will get this. So z equal to 0 is lying outside the closed contour C. So inside this circle, inside this contour, function is analytic. So if inside the function is analytic, then we have studied the theorem. The closed integration of f of z dz over the closed contour will always be 0. Now suppose we have z equal to 1. So z equal to 0, the point at which function is not analytic, singular point, is lying inside. What is happening here? Function is lying inside the circle. So we have studied recently f of z naught 1 by 2 pi iota closed contour C f of z upon z minus z naught dz. So this is our function, and function the singular point lying inside the contour. So we will apply this. Whenever singular point lying inside the contour, it means function is not defined at that point. So f of 0 to pi iota equal to that integration. So it will be 2 pi iota, the value of that integration. Now we have this integration z square upon z square minus 1. It can be written as z plus 1 z minus 1. First we have unit circle centered at z equal to 1. Radius is 1 and center is 1 comma 0. Centered 1 comma 0 and radius is 1. So if this is the point 1 and minus 1 will be outside. Now here 1 is lying inside the contour C. So if z equal to 1 lying inside the function C and function is not analytic at z equal to plus and minus 1, so we will arrange this function in such a way that this will be f of z and this will be z minus 1. Means you have to put that point in denominator at which function is not analytic and that point lying inside the closed contour C. If both point lies outside, then integration will be 0. But if one point or many points lying inside the closed contour C, then our approach will be different to solve the integration. So here z equal to 1 lying inside, so z minus 1 will be in denominator. Now we'll solve it. f of z by z minus 1. We'll use this formula, Cauchy's formula, f of z naught equal to 1 by 2 pi iota f of z minus z naught into dz. Simply put f z equal to 1, f of 1 will be this 1 by 2. So simply put f of 1 equal to 1 by 2, 2 se 2 cancel, pi by pi iota will be our answer of the integration. Same, if it is given to z equal to minus 1, means circle of unit radius, but z equal to -1 is the center. So z equal to -1 comma 0 is the center. Now one point z equal to 1 lying outside, so it's very good. We doesn't have to worry about this point. But this point z equal to -1 is a singular point and lying inside the closed contour C. So in order to solve the integration, in the denominator we have to put z plus 1. So that's how you will approach the question. So z plus 1 will be denominator and this will function will be f of z. Okay, simply 2 pi iota into f of 1. So 2 pi iota into f of 1, f of -1 here, f of -1. So f of -1 will be -1 by 2. So it will be minus pi iota will be answer. Now z equal to 1 by 2. Z equal to 1 by means center is 1 by 2 comma 0. So center is 1 by 2 comma 0. Both point -1 is lying outside, but point 1 comma 0 is lying on the closed contour C. So it's a problematic point. So z -1 will be in denominator, same as above. So z -1 will be in the denominator. Same approach. Okay. Iota will be answer. Now again, suppose we have this question here. So just solve this denominator term. So you can clearly see z equal to 1 will be a factor. So z -1 and z square plus 9. When you solve it, z plus 3 iota and z minus 3 iota. So they are three singular point. Z equal to 1, 3 iota and minus 3 iota are the singular point, and on these points function is not analytic. So z equal to 3 iota, z equal to minus 3 iota, and point 1 comma 0 is lying inside the closed contour C, because it is given to us that the contour is mod of z equal to 2, main circle of 2 radius. So 2 minus 2 and center 0 comma 0. So we can clearly see point 1 comma 0 is lying inside, and 3 iota and 3 iota minus 3 iota will be lying outside. So it is the problematic point. So z -1 will be in denominator and all factor will be in numerator. So z square plus 1 by z square plus 9 will be function of z. So when you solve it, Cauchy integral formula 2 pi iota f of z naught, simply put here and it will be our answer. We have one more questions here. Evaluate f of z minus 1 upon z square plus 1. First is closed contour z plus iota is 1. So when you solve the denominator term, you will get z equal to plus minus iota is singular points, and here is circle of unit radius and center is 0 comma 1, here 0 comma iota. And 0 comma minus iota will be center here. So you can clearly see plus iota and minus iota. Plus iota is where? Here is plus iota, here is minus iota. So both points are lying inside the closed contour C. Sorry, minus iota is lying inside because plus iota is above. So z plus iota will be in denominator. Same formula will be applied. So f of minus iota is iota plus 1 by 2 iota. Put this in the Cauchy integral formula. We have this. So answer will be pi 1 plus iota. It is 1 comma 0 is the center and radius 1. And you can clearly see here if the radius 1, so clearly the value of integration will be 0. Why it is 0? Because we have studied it. If both point lying outside the closed contour C, then integration of the function will be 0, because we have the problematic point z equal to plus minus iota, and here point is not lying inside the closed contour C. we have this equation closed into contour. So when you solve it, x minus x square by 1 upon 1 2 y square, y plus 1 upon 1. The center is 0 comma 1, sorry 0 comma minus 1, and radius is 1, but major axis and minus axis 1 by under 2 and 1. So just draw it. It is 0 comma minus 1, and it is y, so you can take iota, and it is minus 1 upon root 2 minus iota and 1 upon root 2 minus iota. And we have the problem point plus minus iota. Plus iota is above, minus iota is below. So just simply put minus iota in denominator. Means z plus iota will be in denominator. We have solved this above. Integration will be pi 1 plus iota. So what does it refer? If the values of z inside contour is same, then the values of integration will also be the same whatsoever curve is. Means no matter our contour look like this or look like this, we just have to determine the points, singular points. If the singular point, same singular point lying inside and outside of the curve, then no matter what the curve is, the integration will be same. So the value of integration will be same. So the answer will be same. But if singular points are differently showing placement around that contour, then we have to calculate again the value of integration. We have done this. Z square upon z square minus 1 dz around circle center with z equal to 3. So center will be 3 comma 0, and singular point z equal to plus minus 1. So both are lying outside. Both are lying outside means integration will be 0. 2.5. So if center is 2.5, center will be here. Both points lie outside. So again integration will be 0. But if lies inside the integration, then as I explained earlier, integration will have same value regardless shape of the contour. Suppose z equal to 1. So radius is 1. So it is 1 comma 0. So point minus 1 will be outside and 1 will be inside. So z minus 1 will be in denominator. Okay, this will be function. We'll define a function gz where z minus 1 will be in denominator. So 2 pi iota into f1 by 2, f of 1 is 1 by 2, and it will be pi iota. Similarly for z minus 1, center is minus 1 comma 0. So minus 1 is lying inside and 1 is lying outside. So z plus 1 will be in denominator. Solve it. Minus 1 by 2 multiplied 2 pi iota. Minus pi iota will be answer. And 1 by 2 comma 0. So point 1 is lying on the close contour. So z minus 1 will be in denominator. Okay, now you have clear idea about how we are solving this complex integration very easily with the help of Cauchy integral formula. Now suppose it's a radius of 2, so 2 comma and center is 2 comma 0. Radius is 2 and center is 0 comma 0. Two comma 0. Solve it. Integration by parts. Z square upon z minus 1 z plus 1. We'll solve it. So partial fraction method we will use. A upon z minus 1 plus b upon z plus 1. You will get value of a and b. If you don't know, I can explain. Okay, I will explain it. So what we will do here, z square by z minus 1 z plus 1. Here we only solve it. So what you will get, az plus a, bz minus b will be equal to 1. Okay, so a plus b is 0 and a minus b will be 1. So when you solve this, so 2a equal to 1, so a equal to 1 by 2 and b equal to minus 1 by 2. Simply put in the integration, and you can see what you can see. 2 pi iota into f of z equal to 1 है ना. Now we have two different function. F of z is here and both -1 and +1 and -1 points are lying outside the closed contour C. If these are lying inside the closed contour C, then what will you do? 2 by 8, but our function is simply we are doing same, so it will be 0. Now we will discuss about singularity in our further classes. Thank you very much.